Good evening and welcome back to AP Chem Notes. This is 16.7. We're talking about base solutions. We're going to start quickly by talking about strong bases. Strong bases are ones that completely ionize in solution. Completely ionized, remember, means that it's going to break apart in solution. So we're going to say completely ionized, or in other words, completely break apart in solution. So if we're going to draw a picture of a strong base, we can just put our little container here. A strong base is represented by anything you want. We could say OHs, that'd be cool. So let's just say an example. We've got NaOH. We know that's a strong base. It's going to break up into Na pluses and OH minuses. So within our solution, we're going to have a ton of Nas and OHs. And maybe one NaOH that doesn't break apart. But for the most part, it breaks apart completely. So the next part of this is determining the hydroxide ion concentration. So this is just basically finding the pH, or we can find the hydroxide solution or hydroxide concentration very simply. Alright, so if we look at that first one, we've got KOH, so that means it's going to break apart completely in solution. So its hydroxide ion concentration is just going to be 0.225 molar. So that's hydroxide. So to find the pH, we can find the POH by taking the negative log of the hydroxide ion concentration, and then we can find pH by taking 14 minus the POH. So let's go ahead and plug these babies in. So we're going to take the log of 0.225, and that should give us 0.648, and that's our POH. So then all we have to do is subtract 14 from that, which should give us 13.352. An interesting thing on pHs and POHs, you only count for pHs and POHs the numbers behind the decimal for your sig figs. So the fact that this has 3 here, we should have 3 after the decimal in our answer. So our pH is 13.352. If we look at this next one, it's a little bit tougher, but not too bad. We've got 0.0015 molar of strontium hydroxide, but as you can see, we have 2 hydroxides. So for every strontium hydroxide, we have 2 hydroxides. So we have to multiply that 0.0015 times 2, and that's going to give us a hydroxide ion concentration of 0.0030. And there's our molar. So that's like the first question. The second question then says we're supposed to find the pH. We're going to find it exactly the same way we did there. Take the negative log of that. So we've got log 0.003. That gives us a POH of 2.52 with appropriate sig figs. And then we just 14 minus that, and that should give us a pH, not POH, a pH of 11.48. And so, pretty simple on how to solve the strong acids, strong bases. Now, when we do weak acids and weak bases, these guys don't dissociate completely. Right? So they don't break apart completely in solution. In fact, they hardly break apart for the most part. So if we have a weak base, I'll draw our little picture here. Let's pick one like ammonia. Nah, ammonia's kind of tough. Let's pick copper 2 hydroxide. So CuOH2. That gives us Cu and 2 OH minuses, but it's an equilibrium. So what we're going to see is we're going to see a lot of CuOH2s in solution. And depending on the equilibrium constant, we're not going to see very many Cu2 pluses or OHs by itself. The one thing I will note that for every Cu2 plus I have 2 OHs. That's the stoichiometry behind it, so we need to make sure we do that when we're drawing pictures. All right, let's roll on and see if we can't solve this. This is going to be exactly like solving for weak acids. Nothing has changed, so we should start by writing our balanced chemical equation. So it says find the hydroxide ion concentration and pH of a 0.1 molar NH3 solution. Kb equals 1.76 times 10 to the negative 5th. So our first step is again to write our balanced chemical equation. NH3 plus H2O, arrow, arrow. We're going to get NH4 pluses and OH minuses. If we write down our initial concentrations, we've got 0.100, nothing for water, 0, 0, minus X, plus X, plus X. And this will give us 0.100 minus X. That will be X, and that will be also X. If we write our equilibrium constant expression, Kb equals our concentration of NH4 plus times our concentration of OH minus over our concentration of NH3. So now all we have to do is plug these babies in and solve. So we're going to have 1.76 times 10 to the negative 5th is equal to X times X over 0.100 minus X. And just like always, we're going to be able to lose that minus X. And so now we have X squared over 0.100 equals 1.76 times 10 to the negative 5th. All right, it's a terrible 5, so we'll try that again. And so we're going to take 1.76 times 10 to the negative 5th times 0.1 and then we're going to take the square root of that number. And our X value is going to be equal to the hydroxide ion concentration, which is equal to 0.00133. And that's our hydroxide ion concentration, which is the first part. And then we're just going to do what we did before. Change colors again. So to get from hydroxide to POH, we'll take the negative log of that number. All right. And that gives us 2.87. Let's say 2.877. And then we're going to just subtract 14 from that, and that should give us 11 point. Our pH is 11.123. And POH doesn't have a label or pH, you just say that. All right, thanks. See you next time.